All right, so today, last class, we worked on two forces and finding the resultant force. Today we're going to be working with, given a single force, finding another force. If we look at this little force diagram, it's called. We have an object, which is this box, and we have the main force going down, directly down. Does anyone know what the name of this force is?
Gravity.
This is the force of gravity. Does anyone know what the magnitude of a force vector is? Yes, it is always the weight of the object. Now, computing the weight, that's where you use that 9 point whatever number. 9.81. 9.81, thank you. We are not going to be dealing with computing weight. We're just going to be given the magnitude and we're being asked to find other vectors. Now, a force vector can always be broken up into two components. These components are going to be orthogonal to each other or perpendicular. They make 90-degree angles with each other. In this case, the force of gravity is broken up into F1 and F2, right? If we were to redraw this so that the force vector was from 0, 0 in our first quadrant, it can be broken up into the A component vector and the B component vector. This is the exact same picture here. We're just having a different orientation. Does anyone know what the name of this F2 component vector is? Technically, if we were being technical here, this vector should be pushing up on the object like this. Not friction, normal force. This is the normal force. I know, but what? That's a good question though. Hold on a second. Normal force. Why can we draw it downward? Because every single force has an equal and opposite force. So as long as that normal force there has the same magnitude, we can draw it going downward like we did to create the gravity force. Now, again, this F1, technically, the force being applied to this box is going in the direct opposite direction. Does anyone know what the name of this vector is? Friction force. This is our friction force. It is the force keeping our object from sliding down the hill. Keeps the object from sliding down the hill. By the way, we didn't write it. What does the normal force do to our object? It doesn't keep it down. That's what gravity does. Keeps it from falling through the floor. It's the force that keeps everything from just falling to the center of the earth. Technically, it's the force applied to the object from the floor. Okay, so the opposite vector of friction force and the opposite vector of normal force are what create our gravity force. All knowledge that we need to do these problems. So let's go ahead and try it. A wagon with 2 small children as occupants that weighs 130 pounds is on a hill with a grade or incline of 24 degrees. What is the magnitude of the force that is required to keep the wagon from rolling down the hill? What is this wanting from us? Of what? What type of force are we dealing with? The friction force. This wants the magnitude of friction force. So, in our little diagram, we know that the friction force keeps it from rolling down the hill. We also know that this force is equal and opposite to the component force that creates the gravity force. Now remember, the component force is always what compared to the normal force? Perpendicular. So what you can do here is draw a line from the end of our opposite friction force to the end of our gravity force. These two forces together create the gravity force. And what I'm just going to do is I'm going to draw that is perpendicular there. I'm also going to write the magnitude of the gravity force. What is it? 130. Yes. Now there's technically 2 triangles here. We see our red triangle that we just created, but what other triangle is there? I'm specifically looking for another right triangle because I know that I can use Pythagorean theorem and trig on right triangles. The ramp is one of the sides on the other right triangle. And then you go down the gravity force, and the ground is the other side on the right triangle. So there's a blue triangle and there's a red triangle. Does anyone see why identifying that blue triangle could maybe help us? Yes? Exactly. We can use the blue right triangle to find this angle right here. How do we do it? 180 minus 90 minus 24. Because we know that a triangle's angles always add up to what? 180. So when I subtract 180 minus 90 minus 24, what is this angle's value? Why does that help me find the length of V? Now, tangent. So we have to ask ourselves, on the red right triangle, what sides are we given? We're trying to find the adjacent side. That's our V. What else are we given? Not opposite. Look where the right angle is, guys. The 130 is our hypotenuse. What function do we use if we are using A and H? Cosine. Cosine of theta is A over H. What is our angle we're using? 66. What is our adjacent side? Unknown. That's our V we're trying to solve for. And what's our hypotenuse? What do I do to solve for V? 130 times cosine of 66. And I get 52.876. What is my unit for magnitude in this problem? Pounds. That is the force that this man, nope, woman, I don't know, this person is having to exert to keep those kids from rolling down the hill. 52 pounds. It is a lot. So let's hope that person is not weak. I was going to say old. Maybe I shouldn't say old. Are there any questions? So again, the process here. I drew my initial red triangle using the components of gravity. Then I found the angle inside of the red triangle by using the blue triangle's angle measures. Then I identified what trig function I'm using and solved for the missing component. Any questions? You guys try the next one. Now what I'm going to do is I am going to help you draw this in case you misunderstood how to create your drawing. So, a wagon sits on a ramp with an incline of 35 degrees. That means our ramp makes a 35-degree angle with the ground. And here's our wagon. It has a magnitude of 25, meaning our gravity force has a magnitude of 25. Now what we need to do is create our two component vectors that will create gravity. This top one is going to be equal to the force needed to keep it from rolling down. So that's what we're trying to find, is that top, technically friction force. Now, we know this is a right triangle and this is a right triangle. How can we find an angle inside of our green right triangle? 180 minus 90 minus 35, and what do you get? So that's our theta. That's the angle we're going to be using. And what side lengths are we dealing with? Adjacent, which is our friction force, and hypotenuse, which is 25. So you should have done cosine of 55 is equal to our friction force over 25. So to get our friction force, we just multiply 25 times cosine of 55. I guess I am finished solving this. I said I wasn't going to, but oh well. What is 25 times cosine of 55? 14 point, what? 34. And what's our unit? Also, side note, from this point forward, anytime a force does not have an arrow above it, this automatically means the magnitude of the force. Any questions on this problem?